Unit 3 Chemistry, Chapter 2, Part 3, Specific Heat Capacity. So this should be familiar to you from your Unit 2 studies. So this is a review. Okay? When we are giving a substance more energy, the particles within it are going to move and vibrate more. And that's what we are measuring when we are measuring a change in temperature. But the exact amount of energy that we need to change the temperature of something by 1 degree is going to vary a lot from substance to substance. So we can standardize it. We can say how much energy is needed to raise that temperature of that thing by 1 gram of it by a single degree. And that's what we call the specific heat capacity. And it depends upon how strong the intermolecular forces are. If it's only got dispersion forces, it's going to be quite a low. If it's got dipole-dipole, it's going to be higher. And if it's got hydrogen bonds, it's going to be higher still. So water, of course, has loads and loads of hydrogen bonds, so it's a nice high value. Okay, trust me, this is a high value. We can use that to say, well, the energy of changes is equal to the mass of the substance we're changing times its specific heat capacity, that's C, times delta T. Remember, delta is a change. So basically, if we know how much the temperature changed by, and we know what mass it was, and we know its specific heat capacity, we can tell you how much energy went into it. Or if we know how much energy went into it, we can tell you how much of it there was. Or we can tell you what the temperature change was. Okay? So if, for instance, we had 75 ml of water, and remember water has a density of 1 gram per ml, so 75 ml is 75 grams. We're heating it up from 20 to 50 degrees C, so our change, our delta T, is 30 degrees. And sorry if that's deafened you. We know its specific heat capacity. So using those 3 values, we can multiply them together to find the energy that was needed to heat up that little bit of water.